Alright, in today's video, I'll be going over this tutorial. I'll be going over all of the steps in detail. It's creating an accent wall. This one has a contour design where we create random points, move them randomly, and then finish the design by creating the contours. So with that being said, thank you very much for being here. Hopefully you're excited to learn a few more tips and tricks, and let's jump right into the tutorial. All right, so the first component we'll bring in is going to be a plane surface. And with this plane surface, we need to give it a reference plane. I want to create it here in the XZ plane. So let's go here to an XZ construction plane. And then we can plug in two sliders for the X and Y size. So let's go here to 240. And then I'll copy this over, tapping Alt. So we can have a plane surface created here. Now we're going to take this plane surface and divide using divide surface. Now let's bring in a slider here between 3 less than 10 less than 20. So it gives us a slider from 3 to 20 and sets it at 10. And we'll create two of them so we can control the U and V subdivisions. Now notice that even though we have 5 and 5, we actually have 1, 2, 3, 4, 5, 6 points. So that's something we need to keep in mind when we create the surface, because we're using this plane as a reference plane. But now that we have these points, we want to move them in the Y direction. And we'll be moving it in the negative Y direction because we want to move it this way. Now for this, we need to know how many points we're creating. This way we can create a random set of numbers to move these points randomly. So now we'll use random. And now we need to know how many points. So we'll bring in a list length, which will let us know, because once we plug in these points into the list length input and we flatten the input, we'll see that we have 36 points here. We can use that as the number. Then for the range, we need to tell it from what number to what number. So we'll go to construct domain. And here we'll go between 3.00 less than, say, 12. Let's actually decrease that. Let's go from 0 less than 5 less than 24. And I'll use some decimal points to have a little bit more precision here. We'll use the start as 5 and the end as 12. And so that's going to be the range. And the seed is going to be more solutions to the random numbers, because you can have an infinite number of random numbers iterated here. So we'll go here to 3, and then we'll start here at 0. So now here at the end, you'll see that we have 36 points, starting 10.08, then 10.7, then 10.3. But then if we move this, it's going to be a completely different set of numbers. Now we're going to also flatten the input for this, for the move, because we have it as a grafted set and we actually want a long list the same way that we plugged it into the list length here. Now let's plug in the random into the Y direction. Notice that now we have the ability to change the height. And so what we'll do now is take those randomly moved points to create that movement that's random, and we'll bring it back together using surface from points. Now this is where we need to keep in mind the U count. So we'll go here to these points as the input. The U count is going to be here, 5, but we know it's 6, so we do +1. So we always have one more than our subdivision, and then use this as the U count. Also, the way that it creates a surface here, it's not actually going through the point, which means that it's not interpolated. Here we'll go set boolean to true, and when we do this, it makes sure that the surface goes through every single one of those points, which makes the surface a little bit more drastic in terms of the way that it undulates. And so now with this, we can now close the surface between this surface and that surface here. Now here you can make it more random or less random using the subdivision. So if we go here to 5, you can go back down to 3, or you can make it be divided more, and you'll see more undulations here. So let's also hide the original points and the base surface. We can also hide the points that we moved. And what we'll do is take the surface, we'll go to VRep edges, and we'll project them. So here, project curve onto a VRep, but it's actually going to be project an object onto a plane. The plane is going to be this X and Z plane. And what we project is going to be the outside curves or the naked curves. Now we can loft these two together. So we'll graph them. But first, we actually need to explode these. So let's go here to explode. And we'll use this as the input, and then this as the loft input. Then we can take this projected curve and then use boundary surfaces. But first we need to join it back again so we know it's one closed polyline. So we'll flatten this as the input. Notice that now we have the surface back here. Now we can also use this surface here, but this recreates it and makes sure that it goes through the projected curve. And now we can join all of these together. So we'll go to VRep join between the back surface, the side, and then the surface from points. So holding down shift, I'm adding more inputs, and then I can flatten the inputs so it looks at it as one list. And then here at the end, we should have one closed VRep. So what I'll do so it doesn't overlap with all of these other wires, I'll go here to wire display, hidden. And now I can hide most of this stuff. And so we're able to visualize things a little bit better. Let's go here to custom preview. I will hide the wire display on this just so we have this as a standalone, and bring in a color swatch. And I'll change the color here, keep it in grayscale to a dark gray. And now we're able to see the subdivisions. This is going to be in the U or the X. This is going to be in the Z direction. Now I would suggest that some of these numbers here at the start for the domain are not too small, because if they're too small, they'll actually intersect that surface or the back surface. So here I like to keep it, let's go here to like 8. And then here you'll see that we can change the height. Now what we're going to do is take this brep and we're going to go create some contours. So we'll go to contour. We'll use this solid brep as the shape. The point is going to be where it starts from. So we will make sure that we have this plane as the input of where it starts. The direction is going to be in the Y direction. I'll hide the wire on this one because it comes from all the way back here. And if you have it hidden, you can also see it. You just have to click on it to see where it goes originally to. And the distance is going to be the contour spacing. So we'll go here to 1.5. So now let's hide this. And so what we're doing here is saying and creating this contour wall. Now the spacing here is going to be, you don't want it to be too small. So I'll limit the smallest number to be like 0.5. And so now let's take these contours, create a boundary surface on every single one of those, and extrude it in the Y direction. But this is going to be in the negative Y direction, so opposite of here, this way. And we'll be using the same number as the distance for the contours. So using the surface as the base input, we'll be going to Y, negative direction, and extruding those. So now we can take this custom preview, copy it over here, because sometimes we do want to visualize the surface before, but this is going to be now visualizing it now as the contours. So now I'll hide all of this. And so now we have this wall that we can change here. Let's say if we say, oh, maybe that's too drastic, we can go here to 12, make it a little bit less, and then maybe here to 6, or we could add more. So here, let's go to 16. And we can always add more undulation. So if we said 10, and then 10 this way, or even more. Let's go here to 15, and then 15 this way. Notice that here we're creating a type of like topographic design here. And this could be useful for an accent wall, for a ceiling, for a subdivision, for panels. And we could also make it way less, but then increase the depth here. And then if we say, okay, this contour, so let's flatten the input here. This contour is maybe too thick. We can say 0.5 here. And if we don't like this array, we can always go to the seed, which is using the same numbers, but just creating a different solution to it. So what's great about creating a script like this is that you can program it, and you could always come back and adjust the numbers to see if you get a better solution or a better design. Because what we're using here are random points and random numbers, and those can always be adjusted. So let's go here to 5, then 5, and then 0. And so let's now clean this up a little bit. So I'll take this and route it through a geometry component so we know that this is an output. I'll group this. And I'll also group this surface, because there's other designs that we can create with this. So if you don't want the contours to be in the Y direction, you can also make them in the X direction. So let's just do that here. But it's going to be extruded here in the Y direction. So you need to change also this direction. So for this one, I'm going to keep it in the Y direction. Just know that the base form that we created here can be used for other designs. So sometimes you can take a script and reuse it in different ways. It's just what we did to program this one is here at the end, we created the contours in the Y direction. And then we extrude it here in the Y direction. Yep. Okay, so now let's organize this. Like I said, here, the origin, this is where it's going to be created. So we can go to construct point. This is going to bring us a parametric point, but we can always change that location if we want to, place it wherever we want, but it will be on the bottom left here. So I'll group this, go to set 1. This is going to be the X and Y size. This is going to be the U and V subdivisions. The minimum and maximum. And the seed is going to be random. Here at the end, we'll have the contour spacing. And so that concludes this tutorial. Hopefully you learned a few more tips and tricks on how to use parametric tools like Grasshopper for different things. This creates this topographic type of design for an accent wall. So if you have any questions, let me know in the comments below. I will have this available on my website for free for a limited time. And so with that being said, thank you very much for being here, and I hope to see you in the next one.